So I'll demo really quickly an alternative to the rocket style thrust and do kind of this balloon setup here. So I'm using a balloon that came from the 2 million user party pack that Unity put out a couple years ago. You can get that from the asset store. So this balloon, what I want to do is kind of reduce gravity and have it slowly fall to the ground, but rather than rotate and thrust, I want to apply a directional force to it based on AWSD keys or whatever input you want to determine. So I'm going to just deactivate the rocket object. So by selecting the rocket and going to the inspector and just deactivating that game object, it's still there and all the logic's there, but it just won't be active in the game scene. So I have the balloon selected, and just like in the rocket, I'm going to use the parent object to control this. And I'll add a physics rigid body so it falls to the ground. I'm going to ignore the little string here and just really kind of focus on the balloon itself, and maybe even eliminate the string that came with it, or maybe experiment with that as well. But right now the balloon should fall to the ground, and it'll probably fall a little bit faster than we want it to. So the first thing I'm going to do is just going to add that little box collider to it, or maybe a sphere collider, something just to kind of emulate the surface of the balloon. So I'll just tinker with this a little bit, and again I'll just do this really kind of rough and quick. Again, I could be a little bit more accurate, but I think that's pretty much the direction I want to go with this for the demo. Now let me take a look, and I'm just going to temporarily deactivate that string so I'm not looking at that little highlight there. So with the balloon selected, I'm going to add a state machine, and this state machine is going to be the balloon control, and this state will just simply be the player control. This is all going to happen on one state, unlike the last mechanic that we built. We're just going to keep it right in one state. And so this time around, what we'll do, there's a couple of different options, but I'm going to go find the input menu here and look at some of our options, and I'm going to start off by using a get access vector. And the get access vector action is going to do a couple of things. It's going to capture both the horizontal and vertical inputs, the AWSD, and use the same multiplier. Now, once we capture this, we want to change the map. Right now it's operating in XZ, so it's left, right, and forward, foreground, background, which means that if I press the up key, it's going to push it back in Z space once we get this set up. And so really what I want to do is I want up and down to control Y, and left and right to control X. And so I'll just change the map plane to XY. And the get access vector stores the user input in a vector 3. We're only going to use 2 of the 3, but we'll create a new variable, and this, just for now, I'll call it player input. Okay, and because I have debug turned on, when I hit the play button and I start mashing the AWSD keys or the arrow keys, you can see that those store vector, those values change. And just like in the previous video, this multiplier, as we increase it, it'll increase the scale. If I bump this up to 5, now that scale that the player input gets mapped to is now from -5 to +5 instead of operating on just 1 to 5. And we'll see those results. Again, I have my mouse focused in the window, but I'm still just using the AWSD keys, and you can see that when I move left and right, that first value changes. That's the X value. Next is Y, and then of course we have Z, and Z is not being used. So just interested in those first 2 values. Okay, and so now that we're capturing the user input and mapping it and storing it in this vector 3, we're going to use that same vector 3, this player input, and translate that to AdForce. And so I'll go find the physics category, and we'll do an AdForce. And the AdForce, we want to make sure we're adding it every frame. And we're going to use this vector field, that's a vector 3, and so we could use the player input that we captured in the previous action and use that as our force. And so hit the play button, and now when I push up, nothing happens. Could be because we don't have enough force to cause that to move up. And it's kind of, it's rolling when we go left and right. That's just because it's sitting on the ground, and we have a sphere collider on it, so it's causing it to kind of tumble in the ground. So The first thing I'm going to do just to continue to debug this is with the balloon selected, I'm going to go to the rigid body component, and I'm just going to find the gravity, use gravity. I'm going to turn that off. So now when I hit the play button, we still have a rigid body on this object, and it's still using physics, but it's just not using gravity, so it's not falling to the ground. And this is just a real simple, easy way to test. All right, so I can push up and push down. Now, it's not pulling it down to the ground, but now I can kind of push this thing around based on left, right, up, and down. Okay, and so now I can really get in there and kind of play with these values. And so the first thing I probably want to do is definitely set some linear drag on this thing, because if you're following along and you set a similar setup to this, you'll notice that when you take your hands off the keys, the balloon continues to drift almost indefinitely in the direction that you pushed it in. That's because there's no drag. So I'm going to bump up the drag. So with my linear drag up a little bit, that'll cause the balloon to come to a quicker stop. Okay, and just to kind of tweak and refine this a little bit more, I'm going to turn gravity back on, and now because there's drag, it's going to fall a little bit slower. Now maybe not exactly as slow as we want it to fall, but once we're using gravity, that will cause it to fall slower. Now the other thing is that because we're using gravity and because we have drag, that might require you to really kind of tweak the amount of force. So now when I'm trying to test this, that multiplier becomes the amount of force that we're applying to get this thing to move, and it actually didn't move. So I'm just going to bump up that value a little bit and see if I can get this to react a little bit different. Now see, it's still falling really quickly, and so there's a couple of different ways that I can correct for this. I don't want to change the gravity of the entire environment, but I could apply a counterforce on this state. That would be a simple solution. We could also, play with a couple of other values, but just to demonstrate this point, I'm just going to collapse these actions because these are working the way that I want them to. I'm going to do a second AdForce, and this is just going to be a hard value to kind of counteract gravity. And so along the y-axis, I'm not sure what value I'm going to need here, but just start off with 10, and we'll do this every frame and see what happens when we hit the play button. Now that might be cumulative. Gravity's working at like about 9 and some change, a little bit under 10 meters per second, and so we're basically counteracting the gravitational force for this object. So it's not affecting the gravity of the entire scene. If we wanted to do that, if we want to adjust the global gravity, we could set that. We could set that in the project settings under physics. We can see what the rate of gravity is, or what the force of gravity is. Y negative 9.81. We could set the gravity here. We could access that through actions in Playmaker. If we just search for gravity, this will allow us to set gravity inside of our project. So that, we got a couple of different options, but I like this idea of adding force to the balloon because now the balloon appears to be more buoyant. We have control based on our drag and everything else, and we're not affecting the default gravity inside the scene. So if we have other physics-based objects, the balloon will basically act the way that it should. So now, as I move up, we're going to, get probably a slightly more dramatic up motion than we would have otherwise. But you can see that, kind of got the effect that I wanted to. Now it's actually coming to a quicker stop. But anyway, that's just a slight variation on the thrust mechanic. Okay, so in the next presentation, I'll push some other concepts forward. We'll talk about some other mechanics. We'll build a simple camera follow to where we follow our player object regardless of what type it is. So, but we'll do that in the next presentation.